Harris Corporation, Lockheed Martin, Planning Research, Northrop Grumman, U.S. Air Force, and the CIA. Some of the projects we did there, this was our in-house computer, a VAX 11730. It was small. It would handle about 8 users on a terminal. It was capable for developing scientific software like we did. At Harris, now I don't have any pictures of this because, again, this is a classified project, but this data that's streaming down from the satellites had to be converted, had to be geometrically corrected so that when somebody looked at it, they were looking at it in a clear, undistorted fashion. And we had to do this in real time, so it processed the imagery at 2 to 3 million pixels per second. It's pretty fast. So we're using VAX 780s and some special image processing computers for that. There's a VAX 780. You can see it's this machine, little thing over here is called a deck writer, and it was a console that you could type on and also print out results for you. And this happened to be a CRT version of the deck writer. At Northrop, we were working on a project called Compass Preview, again very classified, and its purpose was to take this stereo imagery, pictures of some site on the ground taken from 2 different locations, streamed down to the ground, and let an operator sitting in a console, he would sit at a machine at a big console with a Fresnel lens in front of him. And behind the Fresnel lens were 2 CRTs which projected their view of the scene onto this Fresnel lens. He could look at that in 3 dimensions in real time.
This is what year? Approximately?
This was in the 70s, 1970s.
So when Star Trek was on, you're actually...
I don't remember the date. But yeah, it was pretty interesting to work on. Then for Harris, not Harris, for Martin Marietta, they built a device called a low altitude navigation targeting infrared for night. That is a device which allows an airplane or a helicopter to view a scene in front of them in infrared, and they could detect things that were hot, things that were cold, and they could tell a tank from another device. So the purpose of that was to detect what's a friendly thing and what isn't. The actual device fit under the airplane, or usually it was used in a helicopter to fly with. We developed the pattern recognition algorithms. I say we being GNS, the people there. I was involved with it on this end. I developed a high-level image processing language that we used on a hybrid computer, a VAX and a digital image processor. We also developed a similar system for the Air Force at Eglin Air Force Base. This is what a hybrid might look like, a 780. I don't have any pictures of this, but it would basically take an analog signal, convert it to digital, do the processing in a digital form, convert it back to analog, and then output an analog signal. That was pretty interesting. And this is a lot of words about hybrids. I just put them there for me. Okay, one of the other things I did for Martin, this was fun. The Air Force wanted to blow up enemy landing sites. So they simulated, actually built some landing sites out of, if you see one of these little things here, that represents a 6 by 10 meter concrete block. And they laid them out in this pattern, planted a small explosive underneath the center, and then blew it up. Our job, on top of 2 towers located at some point away from this site, there were very high-speed cameras on the order of 500,000 frames per second. I mean, that's fast. So these 2 cameras would simultaneously take pictures of the explosion as it happened, and then we used what I call block triangulation, and I'll talk, if we've got time. Ooh, we're almost out of time.
Yeah, it's an explosion.
Okay, let me go quickly through this. these are some plots that we came from triangulating on that. The arrows show the direction of motion of the pads and the magnitude, the length of the thing and the direction. And this is a horizontal plot showing which direction it moved, so forth. Well, let me. SAIC bought our company in 1986 and changed it into something called the Sensor Data Analysis. And I did some things there for the Defense and Mapping Agency. And then I was able to go back to the Cape and recommend some things for converting the Cape data processing to a more modern thing. We proposed using a lot of PCs. Unfortunately, we didn't win the contract. Let me just show you a quick thing on what I'm doing now. I've retired in '93, but I like to keep doing things. So this is my business card. We can make a computer do anything but pick cotton. One of the things we did that was interesting, that can help us with, this is a Fujitsu scanner with an automatic document feeder, so that it could read documents at a pace of about 13 or 14 pages per minute. We used that to develop a voting system. This page represents a ballot with a whole bunch of names, and opposite the names there's a number and a couple of little diamonds. And if a person wanted to vote for one of those people, they just marked through both diamonds. If they didn't want to vote, they just left it blank. We also printed a number on the ballot after it was formed so that we could identify the ballot. Then we ran it through an OCR process, optical character recognition. On this side, this column is a scan. This is actually an image. That's a picture of the ballot, or part of the ballot. Over on this side, this is what the OCR software did. You can see in most cases it was pretty good. But notice that where there was a mark on the ballot, you didn't see these double diamonds. You saw something else. So that says they voted for Carolyn Wetzel or Linda Wiersman or whatever. So that worked pretty good, and we've been doing that for several years. The customer is the rural letter carriers of Georgia, Florida, and Mississippi. Okay, and this is where we're going. There's actually technology right now to take input from your brain.
Okay, in those cases you can see from mathematics and computer science what they can do together if you connect, if you have skills in mathematics and computer science. And it seems to me it's many engineering projects and
I'm sorry?
many interesting projects.
Yeah. I had a lot of fun.
Yeah. In this case, maybe in future we will do something together. Maybe we will do something together.
Sure.
And at least I hope we will have more students.
Okay, well that's fine.
Okay, thank you.
I appreciate your time. I didn't bring the whole bomb.
Be lucky.